now. So please don't leave before I take the road. Okay, that's one thing I already say every time about the quiz or test. Every time everybody got the same amount of time. So um, I, I cannot make people retake it. If the whole class didn't do well in the quiz or test, then I will consider to recur at the end of the semester and maybe adjust the amount of problems. But I will not change the time at this point. Okay, I will keep the time. I'd rather change other options instead of the time. So please make sure you submit it before the due time, no matter how many problems you complete. So I'm planning to have one more test in about 3 weeks, just before the midterm grade due. We can still have maybe two more quizzes, and we need to have another test before that. And I planned to have a quiz on this Wednesday, but then I figure out it's not a good time. So I guess we're going to have the next quiz next Monday. Okay. So there will be no quiz this week. We're gonna meet Monday and Friday this week. We're not gonna meet on Wednesday. So you just study yourself on this Wednesday. All right. So that's that. I think we finished the P5 last time. So we're going to start the P6 today. All right. So this is the last section for the chapter for prerequisites or preliminary. So we're going to talk about the rectangular coordinate system and the graphs. Okay. So the rectangular coordinate system is also called the Cartesian plane. All right. From mathematician's name. So we have two orthogonal perpendicular axes, X and Y axis. That will split the whole plane into four parts, and we call them four quadrants. Quadrant 1, 2, 3, and 4. And some people still not sure, which quadrant is which. You start from the upper right with quadrant 1, and then you rotate counterclockwise. You get the quadrant 2, 3, and 4, like the picture shown in the graph. All right. So that's pretty simple. So then we can make some units on each axis. And then we got the different scales in X and Y axis that we can locate the points or any point on the XY plane. So for any point on the XY plane, we can assign a pair of all the numbers. We call them XY coordinates. So the first number is the represents the displacement on the x-axis, the origin, and the second number in the order pair represents the displacement on the y-axis from the origin, like the points plotted on the graph. -1, 2, that be 1. You move from the origin left 1 unit and then up 2 units to get the point of -1, 2, and the point 3 and 4, you start from the origin, move 3 to the right, and then move up 4 units. And 0, 0 is called the origin, as we already know. 3, 0 is just the point you move from the origin 3 units on the x-axis, 3 right 3 units. -2, -3 is just the point from the origin 2 units left and 3 units down. Okay, so this is the coordinates of the points. And then we have the coordinates of the points. Then we can do everything we want. We can find the distance between two points with the coordinates x1, y1, and x2, y2. And that will give the formula the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. So that's the distance formula. And we can also find the midpoint, as we'll talk about later. But let's do one example before that. Let's find the distance between 2 points, 3, 1 and the -3, 0. So we use the distance formula. We take the square root of x1 minus x2 squared plus y2 minus 1 squared. You always subtract the x coordinates and the y coordinates. You don't mix x and y coordinates. You don't have anything like x1 minus y1 or x2 minus y2. That doesn't make sense. Okay. So x2 is -3, y2 is 0, x1 is 3, y1 is 1. Okay. So you can just plug in the numbers. So you got -3 minus 3 squared plus 0 minus 1 squared. Okay. So -3 minus 3 is -6, and 0 minus 1 is -1. So you take the square of those, they become both positive. So -6 squared, you get 36, and -1 squared, you get 1. So 36 plus 1, you get 37, and then you take the root. So that's the distance between the 2 points. Okay, sometimes we can use this distance formula to do some geometrical problems. Like one of the typical problems is to show, the 3 points on the plane make a right triangle. Okay, so like in this example, show that points 2, 1, 4, 0, and 5, 7 are vertices of right triangle. So we need to show that these 3 points make a triangle on the xy plane. And one way to do it is to use the distance formula. You just find out the distance between those points. So let's just name A, B, C, and the coordinates, the points with the coordinates or the vertices. So A will be 5, 7, B will be 2, 1, C will be 4, 0. Then we can use the distance formula to calculate the distance between A and B, B and C, and C and A. Okay. So for example, the distance between A and B, we use capital AB sandwiched by the absolute value sign. So that's the distance between A and B. You just take a square root of the x2 minus x1 squared plus y2 minus y1 squared. Okay. So in this case, x2 will be 1. Y1 will be okay, let's see, x2 minus x1. Okay, all right. 1 and x2 will be 5 and the y2 will be 7. All right, so I just wrote the y2 minus y1 square in ahead, and that really doesn't matter because you're just adding there. So x2 will be 2, x1 will be 5, so 2 minus 5 squared, and the y2 will be 1, and the y1 will be 7. Okay, so you get 1 minus 7 squared. Okay, so then you get again 1 minus 7 is -6, so you get negative 6 squared, which is 36, and 2 minus 5 is negative 3. You take the square, you get 9. So 36 plus 9, you get 45. So that's square root 45. Similarly, AC, the distance between A and C will be what? 0 minus 7 squared plus 4 minus 5 squared. Okay. Again, I just wrote the y part in the front, but again, it doesn't matter since we're adding the numbers. So 0 minus 7 is negative 7. You get negative 7 squared, which is 49. 4 minus 5 is negative 1. So it's squared, you get positive 1. So 49 plus 1 is 50. So at the end, we got the square root of 50 for the AC, distance between A and C. And then we can do the same for BC, the distance between B and C. And so this time, you know, x2 is 4 and the x1 is 2. Y2 is 0 and y1 is 1. So we got the 4 minus 2 squared plus 0 minus 1 squared. So 4 minus 2 is 2 squared is 4. 0 minus 1 is negative 1. Negative 1 squared is 1. So we get 4 plus 1. So that's square root of 5. Okay. So you can, don't get confused about this x2, y2, x1, y1. You can choose any point as x1, y1, or x2, y2. It really doesn't matter, because at the end you're taking the square. Okay, so it really doesn't matter whether it's x2 minus x1 or x1 minus x2. You get the same number, and it's always convenient to draw a graph so that you can read those coordinates easily and they will not be confused. All right, so now we get all the distances for the 3 lines segments. So then we try to use the Pythagorean theorem and see if it holds. Okay, so we if you add the square of AB and the square of BC, so AB square, AB is square root of 45. So if you square it, you get 45. And BC is square root of 5. So if you square it, you get 5. 45 plus 5, that's 50. And that's exactly the square of AC. We already found AC is square root of 50. So that's 50 also. So we got the AB squared plus BC squared equal to AC squared in this triangle. And we know that's exactly what we have in a right triangle. We know in a right triangle the sum of the square of two legs is the square of the hypotenuse. If you can show this Pythagorean relational identity holds for a triangle, then you can claim that this triangle is right triangle converse. Okay, so that's conversely using the Pythagorean identity. In a right triangle, the Pythagorean identity should hold. If in a triangle the Pythagorean identity holds, then the triangle is a right triangle. Okay, so you can use this argument back and forth. All right. The next thing is called the midpoint formula. As I said before, you can always use the coordinates to find the midpoint of the 2 points. So we got 2 points, x1, y1, the x2, y2, and the midpoint, the P, will have the coordinates of the average of those coordinates. Okay, so the x coordinate of the midpoint will be the average of x1, x2, which is x1 plus x2 over 2, and the y coordinate of the midpoint is the average of the y coordinates of the point of the 2 points. So we get y1 plus y2 over 2. Okay, so that mix the midpoint formula with the distance formula. Okay. So let's do one example about the midpoint. So we got 2 points, -2, 8, and 4, -10, and we need to find the midpoint of those 2 points. So what we do is take the average of the x coordinates of those 2 points and the average of the y coordinates of those 2 points. So x1 is -2 and x2 is 4, so we get -2 plus 4 over 2. -2 plus 4 is 2. 2 over 2 is 1. So we get 1 in the first place as the x coordinate of the midpoint. And then y1 is 8, y2 is -10. So 8 plus -10, that's -2. -2 is -1. So the y coordinate of the midpoint is -1. So the midpoint is at 1, -1. All right. So this section is relatively simple, and you know, it should be straightforward. Any questions in this section? All right. If there's no question, then let's just start a new section. All right. So let me just upload the file from my computer. So that's the last section of this chapter. We're going to start a new chapter now. All right. So that'd be 1.1. Right. So we finish the preliminary chapter or prerequisites. So we're gonna start the first chapter of this course. All right, chapter 1. Okay, so chapter 1 is called equations, inequalities, and the mathematical modeling. All right, so we're going to talk about 3 things in this chapter. We're going to talk about equations. We're going to talk about the inequalities, and then we're going to talk about the mathematical modeling, which is the applications of the equations and inequalities. We're going to do some word problems, in other words. And so the first section is about the graphs of equations. Okay, and this is an important topic, and a lot of people have issues with this graphic technique. All right. So let's just talk about the graph of equation to start. Okay. The first example, we want to determine whether 2 points lie on the graph of an equation. So, and those 2 points are 2, 13, and -1, -3. And the equation we have is y equals 10x minus 7. So when we say a point lies on the graph of an equation, it means when you plug in the x and y coordinates of the point to the equation holds. If that's the case, then we know this point is on the graph, because that's how we graph the equation. Remember? So the first point, we just need to show if 2, 13 for the x and y coordinates satisfy the equation of y equal to 10x minus 7. So plug in 2 for x and 13 for y into the equation and see if the equation holds. So on the left, we got 13, that is y, and on the right, we got 10 times 2 minus 7, okay, plug for x. So that's 20 minus 7, which is also 13. So we know this equation holds. So that means the point is indeed on the graph of this equation. Okay. The next point, -1, -3. Again, you just plug in -1 for x and -3 for y in the equation and see if the equation holds. So on the right side, we got y, which is -3. On the left side. On the right side, we got 10 times x, which is 10 times -1 minus 7. So on the right side, we got the -10 minus 7, which is -17. So this equation does not hold. So that means the point of -1, -3 is not on the graph of this equation of y equal to 10x minus 7. All right? Very simple. Okay, and the next example, we try to graph an equation. All right? So how do you graph an equation? Or sketch the graph of y equal to -3x plus 7. What you do is just pick up some numbers for x by your choice. You can choose any points, any x values, and then find the y values from the equation, and then you got ordered pairs, and then you can plot those ordered pairs on the graph, and then connect those points. All right. So in here I chose 6 values for x, and for each of those values for x, I just plug in the x value into the equation and compute the y value. So for example, when x is -1, I plug in -1 for x in the equation. We got y equal to -3x plus 7, so x equals -1. So -3 times -1 is +7, and +3. +3 plus 7, that'll be 10. So y equal to 10. Okay, so that's how we got 10 in here in the second column. When I chose x to be 0, then I plug in 0 for x. So y will be -3 times 0 plus 7 using this equation. And -3 times 0 is just 0. 0 plus 7 is 7. So y equal to 7. And then I chose another point or x values, 1. And then plug in 1 for x in this equation. So we get y equals -3 times 1, which is -3 plus 7. So we got the 4. All right. And then I choose x equal to 2. Plug in 2 for x in the equation, we get a y equal to -3 times 2, which is -6 plus 7. So we get a 1. And next, I choose 3 for x. So we got the y equal to -3 times 3, which is -1 plus 7. So that's -2. And last, I chose -4 for x. So y will be -3 times 4, which is -12 plus 7. And we got -5. So we got 7 ordered pairs. Then you just plot each ordered pair as a point on the XY plane, and you got those points as shown on the graph. And then you just connect those points by a straight line. Okay, it gives us a straight line like this. All right. So that's how you graph. You can also graph any other equations in the same way. So in this example, we want to sketch the graph y equal to x squared minus 2. So again, I just choose some value for x and then compute the y values using the equation. So the x value I chose in this example are -2, -1, 0, 1, 2, and 3. And for each of those values, I plug into the equation for x and find out the y values. Okay, so for example, when x is -2, plug in -2 for x in the equation, we get y equal to x squared, which is -2 squared, which is 4, and then minus 2. So we get the 4 minus 2 equal to 2. And next, I choose x equal to -1. I plug in the equation, so we get y equal to -1 squared minus 2. -1 squared is 1. 1 minus 2 is -1. So we get -1 for y. And then I chose 0 for x and plug into the equation, so we get y equal to 0 squared minus 2. 0 squared is just 0. 0 minus 2, that's -2. And next choose 1 for x. So we get the 1 and y equal to 1 squared minus 2. 1 squared is 1, 1 minus 2 is negative 1. And then I choose 2 for x. Plug into the equation for x. So y equal to 2 squared minus 2. 2 squared is 4, 4 minus 2 is 2. And finally, I choose 3 for x and plug in that into the equation. So we get y equal to 3 squared minus 2. 3 squared is 9, 9 minus 2 is 7. So we got, again, 6 points of all the pairs. And plug those points on the graph. On the XY plane, we got those points. And then you just connect those points by smooth curve on the XY plane. And then we got the parabola opening up. Okay. One of the things I want to tell and to remind you is that you connect the points by a smooth curve. Okay. Don't just connect the points by line segments. You need to make the curve smooth when you connect those points. All right. So it is always a good idea to plot the graph by using the graphing paper. All right. Okay. So the next thing is called the intercept of a graph. The intercepts or intercept of a graph is the intersection of the curve with the x or y axis. Okay, so you want to find the word the curve or graph intercepts or intersects the x and the y coordinate y axis. So how do you do that? Okay, so we can easily read from the graph. Okay, so in this example, we need to identify x and y intercepts of this equation y equal to negative x squared minus 5x from the graph. So the graph is given in the problem. You just read the intercepts in the graph. So the x-intercepts are intersections of the graph and the x-axis, as I said. So there are two intersections between the curve and the x-axis. Negative 5, 0, and 0, 0, right? Okay, so those are the 2 points of the intersection of the curve with the x-axis. And then similarly, the y-intercepts are intersection of the graph with the y-axis. And there's only one intersection between the curve and the y-axis. That's the origin. So the y-intercept is 0, 0. All right? Pretty straight. Next, we talk about the symmetry of the graph. So when you try to graph an equation, you make it some symmetry of the graph that will give you some idea of the shape of the curve, and also you can use the symmetry of the graph to draw the graph itself and save some time, right? So there are 3 types of symmetry for a given equation when you graph it. And the first symmetry is called the symmetry of equation is symmetric with respect to the x-axis. Okay, so that's called the mirror symmetry. The graph of the equation is symmetric with respect to the x-axis. So that means up and down, they are symmetric. The curve is symmetric. And so how do you know the equation has the symmetry? And what you do is just change y to negative y and the equation equivalent or unchanged. So in the equation, you plug in negative y for y, and you get the same kind of equation, equivalent equation. Then you know there's a symmetry with respect to the x-axis for this graph. And the second symmetry is called the symmetric with respect to the y-axis. How do you know the equation or the graph of the equation has this symmetry? This time you change x to negative x and the equation is equivalent. So you change x to negative x in the equation and you get the same equation or equivalent equation. So that's the symmetry. And then there's another symmetry called the symmetrical with respect to the origin. Okay, you got that kind of symmetry also sometimes. This time, how do you know the equation has the symmetry without graphing? Okay, so you can use the method by algebra, like the two symmetries before. Time you change x to negative x and the y to negative y at the same time. And if you get the same equation or equivalent equation, then you know this graph of the equation has the symmetry with respect to the origin. Okay, so that's the point symmetry. It's not the mirror symmetry like before the previous two cases. All right, so let's do some simple examples. Okay, test y equal to 2x cubed for symmetry with respect to both axis and the origin. So we need to test the symmetry of this graph for the three symmetries. So let's just do the symmetry with respect to the x-axis first. So what you do, you change y to negative y. Okay. When you symmetry with respect to the x-axis, you change y to negative y and see if the equation holds. So if you change y to negative y in the equation, then we get negative y equal to 2x cubed. And this equation is not the same as the original equation y equal to 2x cubed. Okay, so there is no symmetry with respect to the x-axis. Next, let's test the symmetry with respect to the y-axis. This time, you change x to negative x and see if the equation is still the same as the original equation. So change x to negative x in the equation. We got the y equal to 2 times negative x cubed. And negative x cubed is just negative. So we get a y equal to negative 2x cubed. Again, this is not the same equation we had originally, which was y equal to 2x cubed. So that means the equation does not have the symmetry, or the graph does not have the symmetry with respect to the y-axis. Finally, let's test symmetry with respect to the origin. So now we plug in negative x for x and the y to negative y at the same time into the equation. So on the left, we got negative y equals the right 2 times negative x cubed. So again, negative x cubed is just negative. So we got the negative y equals negative 2x cubed. And if you multiply negative 1 on both sides, you're going to get a y equal to 2x cubed. So that's the same equation we had originally. So that means the graph of the equation does have the symmetry with respect to the origin. All right. And you can see the graph of this equation or function. You know, it has the point symmetry. Okay. All right. Next, let's just use symmetry to sketch the graph of an equation or function y equal to x squared minus 4. So we have to test the symmetry first. Okay. So let's see if the graph has the symmetry with respect to the y-axis. So what we do is we change x to negative x and see if the equation holds. So if we change x to negative x, we got y equal to negative x squared minus 4. But negative x squared is just x squared. So that's just the x squared minus 4. And that's the same as on the right side of the original equation. So the graph does have a symmetry with respect to the y-axis. Okay, so then you can just plot the plot on either the left or the right, and using the symmetry to reflect the other plot on the left or right. Okay, so that saves us a little time. So we just plot the right part of this graph and reflect it to the left. And so let's choose x equal to 0, 1, 2, and 3. and plug in 0 for x, we get the y equal to 0 squared minus 4. So 0 squared is 0. 0 minus 4 is negative 4. Plug in 1 for x, we get y equal to 1 squared minus 4. So we get the 1 squared equal to 1. 1 minus 4 is negative 3. And then plug in 2 for x, we get y equal to 2 squared minus 4. 2 squared is 4. 4 minus 4 is 0. So that's the third point. And finally, choose x equal to 3. So we got the y equal to 3 squared minus 4. So that's 9 minus 4, which is 5. So we get the 4, all the pairs of 4 points. If you plot them, we got the right hand part of the curve if you connect those points smoothly. And then you just reflect the right part about the y-axis, you get left part. Okay, so you don't have to pick up any points on the left part of the graph or the curve. So that saves a little time for us using symmetry to graph. All right. Okay. Let's do another one. Okay. This time we need to sketch the graph of y equal to absolute value of x minus 1. So we can use the previous techniques to check if there is any symmetry with respect to the graph, with respect to x or y axis or the origin. And if you do that, none of them satisfies. So I will not show the details in here, but you can easily see that there's no symmetry with respect to the x-axis or y-axis or the origin. So this time you have to plot a bunch of points. Okay, so you do check the symmetry first. If there's a symmetry, then you can plot fewer points. If you don't have symmetry, then you have to plot more points. Okay, so let's just plot this graph by choosing 7 points or 7 x values. So if you choose x equal to -1 and plug in -2 and plug in -2 in the equation, we get the y equal to absolute value of -2 minus 1. -2 minus 1 is -3. You take the absolute value, you get 3. And then you choose -1 for x and plug in -1 in the equation, you get -1 minus 1, which is -2. Take the absolute value of -2, you get 2. And plug in 0, the next point or next value of x. X equal to 0. 0 minus 1 is -1. Take the absolute value of -1, you get 1. And then you choose x equal to 1. So plug in 1 for x, you get y equal to absolute value of 1 minus 1. So that's 0. Absolute value of 0 is 0. And then choose x equal to 2. Plug into the equation y equal to absolute value of 2 minus 1. 2 minus 1 is 1, so you get the absolute value of 1, which is 1 also. And then choose x equal to 3. So y equal to absolute value of 3 minus 1. 3 minus 1 is 2. Absolute value of 2 is 2. And then finally we choose 4 for x. So we get y equal to absolute value of 4 minus 1. 4 minus 1 is 3. So absolute value of 3 is 3. So we got the 7 points or 7 odd pairs to plot on the XY plane. And then you just connect those points with a smooth curve. In this case, it turns out there are 2 straight lines, okay, like this, like a V-shape curve. All right. So that's the graph of y equal to absolute value of x minus 1. All right. Okay. The last thing I want to talk about today is the circle. Okay. When we talk about circle, it includes 2 things. The first, we need the center of the circle, and then the other thing we need is the radius of the circle. Then once we know those two things, then the circle is uniquely determined. All right. So the standard form of circle with radius r and with the center at the point of hk is given by the following equation: x minus h squared plus y minus k squared equal to r squared. So that's the standard equation for a circle. H and k are the xy coordinates of the center, and r is the radius of the circle if you look at the graph. Okay. So in this example, the point 1, -2 lies on a circle whose center is at -3, -5, and we need to write the equation of the circle. Okay, so as we said, we need the center and the radius to write the equation of the circle. We already know the center is at -3, -5, so we need to find the radius. It's not given in the problem, but we can calculate the radius from the point 1, -2 to the center. That the distance between those 2 points gives the radius also, right? So just use the distance formula. So the radius or d is just square root of x2 minus x1 squared plus y2 minus y1 squared as the distance formula. So you can, name x1 equal to -3 and y1 equal to -5, and x2 be 1 and y2 to be -2. So you plug in those numbers, you get 1 minus -3 squared plus -2 minus -5 squared. So 1 minus -3, you get 4. 4 squared is 16, and -2 minus -5 is just 3. Okay, that's -2 plus 5. So 3 squared equal to 9. So 16 plus 9, that's 25. Take the square root, we get 5. So the equation of the circle will be x minus h, which is -3, plus y minus -5, which is k squared, equal to r squared, which is 5 squared. And simplified or rewrite, you get x plus 3 plus y plus 5 squared equal to 25. 5 squared is 25. Okay. So that's the equation of the circle. All right. That's the x, y, and the coordinates on the circle have to satisfy this equation. All right. Any questions? So I guess we're done today, and I'm going to take the role if you don't have any questions now. Try to make up the quiz test if you missed them. Don't wait. All right. Let me take the role, and then you can leave. Let's see. I think I got it. So, wait. Did anybody just join? Okay, let me just do one more time. I think it's good. Might be good. Yes. Okay, it's good. So, any questions? You can leave now if you don't have any questions.
I was wondering if I could take my test now.
Did you miss it? Did you take it?
I mean, no, I never took it. Remember, I had to get my access code. I was wondering if I could take it now.
Okay. Yes. 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 Just call my cell number, then I can arrange it for you. I got the number 256-257-8931. Is that anybody in this class? So that's another. That might be another class. Okay. Yes. Yes. You can take it now. Just be real quick. Now, okay. And I think it's better to do it after 4 today. I have another class at 3. So, but it will take a little time. Yes, you make up. Yes, yes. Please do it after 3, after 4. Okay, today. We have I have another class at 3, and you may not be able to get it done before 3. You need to set up the things. So call my cell number. Okay, call my cell number after 4. Okay, all right. If you didn't take it, just make them up. If you took it, you cannot retake it. Okay. Okay. All right. So if you don't have any more questions, then I'm going to stop recording, and I'm going to leave. And you're free to go now. Again, we don't have class on Wednesday. We're going to have a class on Friday. And I'll put the quiz on next Monday instead of this Wednesday. So there's no quiz this week. So see you Friday.